Okay, this lesson is on classifying stationary points. Stationary point occurs when the derivative is equal to 0. When the derivative is 0, your curve kind of flattens out. Okay, that's a stationary point. It can be a maximum or a minimum, or it can be possibly a point of inflection. Now, for a maximum and a minimum, the slopes change. For a maximum, the slope goes from positive to negative. For a minimum, the slopes go from negative to a positive, and right at the middle is the slope of 0. For a point of inflection, I have a slope of 0, but my slopes around it don't actually change. It can go from positive to positive, or conversely, it can go from negative to negative. Okay, so I want to find and classify any stationary points for this. So if I take my function, first thing I want to do is find that maximum or minimum point. So I want to find when the derivative equals 0. So I'll take my derivative. In this case, it's just going to be simply 2x. I want to make my derivative equal to 0. So 0 is going to equal 2x. I'm going to solve. And in this case, I'm going to simply just get x equals 0 and divide both sides by 2. So at x equals 0, okay, my derivative was 2x. And at x equals 0, something is happening. So let's plug in, let's take our derivative, and let's put in values around that x equals 0. So let's put in like -1, and let's put in +1. So when I put in -1 into this equation, I want to get a negative slope. Okay? When I put in a +1 into the derivative equation, I want to get a positive slope. So I test values on either side of that stationary point. So when it goes from a negative slope to a positive slope, that means at that point, okay, this must be a minimum. So at x equals 0 is a minimum. Okay, let's take one that's a little bit more complicated. First thing I want to do is take the derivative. My derivative is going to be 3x squared minus 3, and then the 2 is just going to go to 0. I'm going to make the derivative equal to 0. Okay, so I'm going to have 0 equals 3x squared minus 3. I'm going to need to solve this. So what I'm going to do is I'm going to common factor out of 3, be left with x squared minus 1. That is difference of squares, so it goes x plus 1 and x minus 1. All right, so, and then I can solve each one of these brackets, so x equals -1, x equals +1. So I test those two values. So I set up a little interval. Okay, so those are the values I know where the slope is 0. My slope is 0 at those points. At -1, +1, I know my derivative is 0. So let's test points around that. So something a little less than -1. Well, let's test -2. Something between -1 and 0, let's test 0. And let's test something a little bit bigger than +1, so let's test the value of 2. When I put in -2 into my derivative, okay, that will give me -2 squared. That's all I need to know if it's going to be a positive or negative value. -2 squared is 4. 4 times 3 is 12. And 12 subtract 3 is 9. That's a positive value. Let's put in a 0 into the derivative. So 0 goes in. Okay, I'm going to get, so that's going to give me 3x squared. So that's going to give me 0 times that times 3 is still 0. Subtract 3, that's going to give me a negative value, a negative slope. Put in a +2. 2 in, 2 squared is 4. 4 times 3 is 12. 12 subtract 3 is 9. 9 is positive. So I have it going from positive to negative, then back to positive. So that means at x equals -1, I have a maximum, and x equals +1, I have a minimum. So at x equals -1, I have a max, and x equals +1, I have a minimum. Okay, so that's how I test my stationary values. I can also figure out intervals of increase and decrease. Is I find out when the derivative is equal to 0, and then I test values on either side of that. Okay, and see what's kind of going on. Gives me a picture of the slope. So the slope's negative, the slope's positive. Okay? Thank you very much.